Hello, guys. Today we are going to talk about a new repository that has been recently launched by Facebook Meta AI. And this repository is about the Segment Anything. So, Segment Anything is a repository, is a project that can segment out any object in image or in a video. Uh, Segmenting task has been very challenging in the computer vision discipline. And using this repository, it will be quite easy to segment objects in the images, in the videos, and it will help out annotating the annotation job or annotation task. So let's move on the on this project on this page and see how it works. So this is the main page of Segment Anything. Segment Anything released by Meta AI. So in this, what it says that AI model for Meta that can cut out any object in an image using a single click. So using a single click, you can segment out any object. So Sam uses a variety of input prompts. So what we need to do is that most of the cases we have to provide some prompts. So what the prompt is, prompt could be some sort of click on the object in an image. It could be some bounding box, or in higher level, it could be some text that you provide that what you want to segment from the image. The other option they provide is that you can segment anything in the image. So you can segment everything in the image. Uh, it automatically detects everything in the image. And the third option is that it generates when you provide some prompts and it segments out the objects. But sometimes there is a difficulty that whether you want to segment out the jacket or you want to you want to segment all the statue. So in this case, so it provides a variety of the mask, multiple valid mask. That then you can choose one of them. And then SAM's promptable design enables flexible integration with other system. It could be integrated with other system. For example, SAM could be used in augmented reality, virtual reality, where human gaze in augmented reality or virtual reality, it will be taken as an input and object that the person is focusing in the image or video. It could be taken out from the video, or the input can be some text. So we provide some text and it will segment out all the objects in the image. For example, if provide the cat and it will segment out all the cats in the image. Then extensible outputs of the SAM could be that you could use it other AI system. For example, you can use the mask tracking videos, engaging image editing applications, 3D reconstruction, creative tasks like blogging. You can use these masks where you have to put different mask on one image or background. Uh, the segment anything can also be used for the zero shot generalization, where you provide the data, where you test this SAM model uh, on the images which have not been used for the training. That's zero shot generalization, zero shot segmentation. So, and it can be used to segment out unfamiliar objects in the images or the videos. So, for example, detecting objects from or segmenting out subject objects from the segmenting out objects in the cell structure, segmenting out objects from the painting or some ocean images like this. So then there comes the demo for the segment anything, and we will subsequently move on this demo. But before that, we just little bit get what this structure is. So same data engine, it includes two things. One is the data and another is the model. So what the SAM does that data loop, they keep on increasing the data and keep on training the model, and then subsequently the performance keep on increasing. So that's why this data engine, SAM's data engine, it includes keep on increasing the data and keep on modeling training the model. So One thing the Meta AI claims that they include a lot of images, billions of millions of images. They include 11 million images, and these are the privacy protected and licensed images, and they include the 1 billion mask. If you say that 11 million images, it almost covers all the objects a person interact in his life, or 1 billion mask, 1 billion objects, more than 1 billion objects. Is that all you include or face in your daily life? Bicycle, bus, cup, mobile phones, laptops, clothes, everything it covers. So you can say that this model can segment out anything in the images. So then you can download and see this data set. And talking to the model, the basic idea is taken from the vision transformer, where you have the images and images used, and then it comes the image encoder, which generates the image embedding, which generates the embedding. And the other side, the novelty they claim is that they included prompt, which is inputs. Uh, these prompts, as I told before, it could be the points, mask, or they could be the box or text, or even maybe some voice in future. So that would also be taken as input. That would also be used. That will be used in the prompt encoder, and that will be helped to mask detector mask. That will go into the mask decoder, and then it will generate the final mask. So this is the high level understanding of the algorithm. Except using only the image embedding, they also use the prompt embedding as well. So this is the main architecture. Let's go to the demo of this code, where we go to the demo. And for the demo, so this is the demo, and this is the main page for the demo. I upload an image on it. So for example, I have an image. So it is uploading my image. And now you can see that as I hover my mouse, it detects the different objects in the image. Like let's say sky, it detects domes, it detects cap, etc. or something. So then, for example, I click on the cap. So it says that cap has been detected. So now I cut out this object. So cap has been cut out as an object. Then I say that there is a DOM, and now the DOM has been detected, and I cut out this object, so it goes here. And then it says that there is sky. So I click here and it detects it cut out the sky. So sky has come. So this is one case. This is the prompt using the mouse input or by clicking. Then the other kind of prompt is the bounding box. So I generate a bounding box around an object and it will detect that object. So for example, I generate the bounding box across the mask, and this face mask has been cut out. So you can see I created a bounding box around my body, and it has generated the this. Now I will cut it out. Okay, so this is the way it works. So then the third type of version is that segment everything. So I click on the segment everything. So it will detect everything in the image, and it will create the mask for everything, segment out everything in the image. And now I can cut out all these objects. So I guess it's working on these objects, and now all these objects have been segmented out. Okay. Now all these objects, they can be cut out. Now you see every object has been cut out. Clouds, everything, walls, mask. So this is the way that it works. So then the code, blog posts, they are provided, but we will go towards uh, um, the Python code for this project. So here is the Python code for this project. So I am going to run it in the Google Colab. So first of all, I upload an image, and here I am going to upload an image for it. So, and then I run the first command. What this command does, it installs the segment anything repository. And importing this PyTorch, Torch Vision, and importing some libraries. And here it is going to show the image, what the image looks like. And then it is going to load the model, downloading the model. Okay, and now here is going to apply this uh, segment anything uh, on this image shown above. It will take a couple of seconds, maybe 1 minute or so. So we will have to be patient for that. Okay, it says that 35 objects has been detected. And now we are going to plot the those images, those objects on the image. And here it shows that these are the different objects like trees, this tower or lighthouse, and these are some trees, other trees, vegetation, clouds. So this is the way that it has plotted, identified 35 objects in this image. So this is all about the segment anything. So it's a really very interesting project that will prove as the chat GPT for computer vision, because segmentation or image segmentation, it has been a very difficult task for the computer vision community. It would be extended towards the input would be extended, for example, the voice, and then you will say that let's say you will say that cat in the image, and it will detect all the cats, because currently they only provide the text, but the input could be voice. You will say that cat in the image, and it will segment out all the cats in the image. Then you will say that um, cat in the video, it will detect all the cats in all the frames of the video. So that will be very interesting application. Also, this application will be used for the practicing the doctors who practice using the virtual reality, augmented reality for the surgery of abdomen, and they have, before going to a live patient, they practice choosing uh, uh, different organs and practicing using the AI, virtual reality, augmented reality. It can help them, those doctors as well. So let's see how the things go on, and I'm very optimistic about the revelations that this project will bring. Thank you so much. Thanks for watching.